early. Give people a few minutes.
Yeah, I just saw the link and clicked on it when it pops up.
Oh, cool. Are you in Switzerland?
No, I'm in Berlin at the Ethereum office.
Oh, okay. Yeah, I'll probably be in Berlin in June.
June. What's happening in June?
Oh, I'm just gonna go hang out with the Ascribe people.
Okay. Oh yeah, they're the big chain DB people.
Yeah.
Is Big Chain interesting at all? I thought it was.
I mean, it's not all that interesting to me, but you know, they seem to be working hard and, you know, trying to do things slightly differently. So I want to hang out with them and kind of give them some ideas from the formal methods community. They're coming at a slightly different angle. Wow, what's that?
That looks like Aaron's arm.
Hey, Aaron.
Hey. Greetings from the Marriott.
All right.
Where are you at, Aaron?
I'm at the Consensus Conference in Times Square Marriott.
Ah.
Okay. So I can't remember. I know Vitalik is speaking there. Is Vlad speaking there? Oh, no, probably not.
I think he said he'd show up in the lobby, but I haven't seen him yet.
Okay. Cool.
Okay. Let's see.
Is Transactive Grid speaking at the conference?
Hang on, let me call up a schedule. Yeah, so I can't see them, the Transactive Grid in the schedule.
Oh well.
But I was reading about the project. It was interesting. It's also, I think it's funny that all of this stuff is happening back in my old neighborhood just after I leave.
That's very funny. Yeah. Well, it may be just us. I know Vitalik has a panel now, and so he won't be joining us today. And I think Vlad is on a plane. So I can give a very quick update. So I've gotten much more excited about implementing the vetting by propositions and so we're in the process of going forward with the nested Casper architecture that I presented a few weeks ago, and we've got already a parser for the contracting language in which we'll write the bedding in which we'll write the the VM. So that's actually moving along at a very good clip. Our VM is quite likely to be, well, I mean, I described it before. There'll probably be some influence from the VM described in the Peyton Jones, Amir, let's see, Sabri, and Dybvig paper. So that's kind of what we're doing. I did realize that with respect to the straight up bedding cycle, we have there's an economic pressure that I need to like if I'm how do I describe this? Vlad's is it working?
Kind of.
Okay, cool. All right, so I was just saying, I was just giving a very quick update. So we're getting we're making a lot of progress towards implementing the whole nested Casper thing that I described some weeks back. We've already got the parser for the language implemented, and we're now moving on to the compiler for that language, which will then utilize to write Casper as contracts in that reflective tower.
Cool. And so you're working with Jack on this, or?
Yeah, Jack and some others. So.
Great.
Yeah.
Is there anyone else that I should know about?
We're hopefully bringing on an economist.
Oh, great.
Rugaya Tabrizi. You should meet her. She's a really interesting person. She just defended her PhD thesis. So yeah. I'll get you guys introduced. Yeah, so that's but I realized that like in the logic for, remember how we had this discussion about whether or not there are two betting cycles, a betting cycle on the propositions themselves and then a betting cycle on the maximal consistent subset. Right. So you don't have to. You only have to bet when there's a conflict. But the question. So you don't have to bet on the propositions, but you do want to have some kind of drivers, because otherwise people will seek the conflicts, right? Because that'll be the first time you actually have a betting cycle, and you don't want to incentivize conflicts. So you have to kind of tweak that in a slightly different way.
I don't really get it. So why would we be incentivizing conflicts?
Well, the thing is, if you only bet on conflicts, or you only initiate a betting cycle when you have conflicts, then that's when people can when validators can potentially make more money, right? So it incentivizes.
Are betting cycles profitable? In my world, I only really have like loss, and then like they get transaction fees no matter what.
Okay. Well, so how does that work? So people bet on. Did they bet on?
They would like expose themselves to loss in the event that these propositions don't turn out to be true, and so like there's no actual like the incentive to do it is to basically get transaction fees. So So actually, I guess in your model, like you might be paying fees out even when there's no betting cycles.
No, you don't have to. You don't have to pay fees when there's no betting cycles. I just wanted to make sure that the betting cycle is not uh, the means by which someone is rewarded, right? So, and I would see. I'm not sure exactly how you you got to incentivize parties to bet in the first place, right?
Mm-hmm. Well, I mean, kind of.
So exposure to loss is not an incentivization
No.
scheme, right? So how does that work?
Well, I mean, the way it works is that they only get transaction fees when they expose themselves to loss. So for me, like I kind of require these betting cycles. But the reason really is that I want to give clients finalized claims, right? I want to give clients assurances. Whereas, like, you know, no betting cycle means no assurance that like some conflicting thing isn't getting. Whereas, like, the betting cycle does give you assurance that a conflicting thing isn't getting it. So as a client, I'm not going to be aware necessarily of all the possible, you know, conflicts, and I'm not going to be aware that there isn't a conflict when there isn't.
Right. Okay. Yeah. I think I understand what you're saying. Yeah. So essentially, what I'm trying to do is to find the natural point whereby a betting cycle is triggered.
Greg, can I ask a clarifying question?
Yes, please.
You're saying that because we have to incentivize bets, or if we incentivize bets, then it's potentially profitable to take part in betting cycles. And if bets only happen when there is conflict, we're incentivized to create conflict so that we trigger our both resolving that conflict.
Yeah. Exactly.
Yeah,
Okay,
I mean, I don't actually think that's great. I think that like betting cycles are there mostly for the client's benefit rather than for the sake of the consensus. And like the clients like need to like get information from these betting cycles because like they don't know any better, right? They're not actually watching all these blocks of info. And you can actually really justify paying transaction fees for that because like, it is serving a client request.
Good morning, ladies and gentlemen. Stan speaking. Welcome on board Air Canada Flight 706 from LaGuardia to New York LaGuardia Airport. Ground crew's just finishing uploading all the bags. We're all done in front. We'll be pushing back on scheduled departure time. We're going to spend a little bit of time on the ground. Air traffic control.
Are you? You're not in the air yet?
No, yeah.
Oh, okay. Okay. Well, I would like to find just a natural. I mean, it seems like the most natural time to initiate a betting cycle is when you have, you know, more than one maximally consistent subset of propositions.
We're flight line at 20.
Yeah, I kind of see that, but you also kind of see what I'm saying about the client request, right?
On the way to LaGuardia, so get the belt on.
I'm not quite following it. Maybe you can help.
Sure. So if I make like a transaction, I'm gonna want some information about my transaction receipt, and unless the betting cycle, I'm not sure actually if there's like a conflict or like how many. I don't have like a commitment, right? I don't have like value and costs exposed to the correctness of my transaction receipt.
Right. Yeah, exactly. So that's kind of right at the nub of what I'm trying to get at. So like, what if the validators were so harmonious that they had, you know, that they were able to do, you know, 1 million rounds of proposing propositions without ever having a conflict?
Oh, that's great. I mean, but so to me, but they're still involved in a betting cycle. It just instead of having like more than one vertex, it only ever has like one. And the reason that I call it still a betting cycle is because it is exposing them to loss in the event that this proposition turns out to be false, which is what clients need in order to like understand blockchain, basically.
Right. And I guess what I was saying was that I would want to limit the length of these harmonious runs in some way, right? So that, you know, after some period of you know, harmonious interplay, there's a forgetting,
Oh, I mean, it should. If it's harmonious, it should finalize extremely quickly. You know, there's no competition. It should.
Yeah, but then so like could one validator make a proposition and say, okay, I didn't see any conflicts. Okay, I'm finalizing that. We're all done.
No, they couldn't, right?
Right, exactly. So what's between those two extremes, like an infinitely harmonious interplay, and one validator just like rushing, putting in a proposition and saying, okay, that's finalized. You know, what are some natural events?
I mean, why not have all the validators bet until it's finalized and then they stop? I mean, like that could be like, you know, a few rounds betting. There's no conflicts, right?
Yeah, so I'm just not sure what the Rick, welcome.
Rick.
Oh, hi. I had no idea if this was still going on.
Oh yeah.
Just started.
Oh, great.
So we were just having a discussion about when betting cycles terminate.
Actually, I was talking about when they initiate.
Oh, okay.
Not when they terminate.
So what you want is to not have an arbitrary number of them. It'd be initiated.
Well, what I want is some understanding of if there are any natural events that trigger betting. So,
Oh, okay. I thought you were wondering about natural events that make betting end.
no. I mean, betting ends at least for a particular when you've converged, right? When you've got convergence, then.
Although potentially the maximally equivalent subset thing can get us around that and have a little bit more of a, you know, functioning even without convergence, I think.
Well, the maximally consistent subset thing is how you detect conflict. If you have more than one maximally consistent subset, then you have conflict. Different parties have different views.
But the idea is that like you could kind of like roll up undecided betting cycles into this maximally. I mean, any undecided betting cycle is going to be a conflict that is going to add like dimensionality to the maximally subset betting cycle.
Right. I mean, so anyway, I mean, kind of the spectrum we were considering, Rick, was, you know, in the case where you're betting on propositions rather than on blocks. What I've been thinking about is you're not actually betting on propositions. You're just betting on maximally consistent subsets, because that's where you have conflict. And so you can have validators proposing propositions, and if there's never a conflict, you could have extremely long runs of propositions. And at what point do you say, okay, boom, you know, I'm now materializing a blockchain that satisfies all of the propositions.
So why don't you want to do that like every X seconds?
Well, that's one way to do it. That's a mechanism.
So like that's something that like, I mean, so the main kind of trade-offs are like between overhead and latency, right? I mean, like clients want these things to happen very quickly, so that way they can like get their receipts confirmed. But that's going to create higher overhead, which means that there's going to be lower capacity. But I mean, do you see any other trade-offs?
Well, again, if the propositions describe, you know, particularly large chains, then you can, you know, you can get these kind of jerky but blazingly fast throughput speeds, right? So, like, you know, if you waited, for example, until everyone had had a chance, every validator had a chance to make at least one proposition, then you might, you know, at the end of that round, be forward by 1 million blocks.
Yeah, I mean that's fine potentially.
Right. So within what like those communications could happen in a few 100 milliseconds, and so you could get potentially a million block. If there was no conflicts, you could get a million blocks in a few a few thousand milliseconds.
Sure, yeah. And I mean,
Phenomenal rates, right?
sure. I mean, as long as like, clients don't have to wait too long for them to know their transaction receipt.
Right, but in the scenario I'm describing, they get their transaction receipt, within a few thousand milliseconds, so a few seconds.
Yeah, a few seconds. Yeah, I mean that's basically what I would aim for.
Shouldn't it be like a function of some sense of size and time? So time makes a lot of sense, but I think to go with what you were just saying, shouldn't there also be something about the size of the thing that's being solidified into a block?
Well, okay, so let's go with that intuition. What I mean, how do you measure this? What's a reasonable size?
Well, I mean, so one thing that we have is the idea of a gas limit, right? We don't want to have more than X computational resources required per second to keep up with the network. So definitely there needs to be there's some rate limiting with respect to size.
Yeah, I'm not sure. I think gas makes sense. I think if you can say, well, we'll have to execute 40 million state transformations here, so let's make a block now so we can do those. I feel like that's sort of like a limit as well. It'd probably be lower than that number.
Yeah, I mean, I think that's reasonable.
Yeah, but all of those feel somewhat arbitrary, right? They don't have a with gas. The interesting thing is that it seems like what you really need is gas per unit of time, right? Not
necessarily. No, what you need is
what
per unit of time that it takes the smallest node you permit on the network to sync up, right? I mean, the different nodes will take different amounts of time to compute the same transitions.
Okay.
And the important thing is that nodes, if after they go off for a long time, still have the capacity to come back online and resync by processing all the transitions they missed.
Yeah, but I mean, I want to point out there's an intrinsic gas per second rate that falls out of the target block speed and gas limit.
Yeah, so the question is what's the gas limit, right? I mean, I like to think of the gas limit on a per second basis, but that's just because I find it more convenient than per block for thinking about in scaling situations.
But Martin, in the proposition case, there isn't necessarily a block speed, right? The block speed can be all over the place.
Right.
You mean the time between blocks?
So think about it this way, right? So when a validator proposes a proposition, that proposition may describe, any number of possible blockchains, from a blockchain that is 10 further down the line, a height of the height plus 10 to a height plus 1,000,000, right? And then a bunch of other validators will all propose propositions that are capture the requirements of their clients. And then at a certain point, a picture emerges of what are the consistent propositions, right? And at that point, the blockchain could be synthesized, but that may be 1,000,000 more blocks, 10 million more blocks, 5 blocks. There's no guarantee on a block speed.
Right. All right. Yeah. Sure. Like when it'll be finalized. But intrinsic, subjectively to contracts, I guess there is a speed at which they're running. The same way there's like intrinsically a time to us, right?
I could see a transaction per second clock.
Okay, that works.
But the transactions don't have timestamps blocks too, right?
Right, but each node would still be counting how many transactions they see within some slice of time, and the slowest, again, it's slowest wins or whatever.
But in any case, we need like a gas limit, right? I mean, we're not going to be dispensing with the gas limit because if we do, then validators could like make things that they can validate, but other validators can't.
Yeah, of course. So, but the gas limit.
Who's in the conference? Who's doing this meeting in a conference? Is that you, Vlad?
No, I'm in an airplane. We're about to take off, and I'll be in New York in like an hour and a half.
Oh, cool.
Yeah, we should hang out.
Yeah. Oh wow, that's amazing. So yeah. So I think I was going to say something about transactions and oh yeah, the gas should be. The gas is only determining the validity of the transaction, right? That's not determining when we collect those transactions in the blocks, right? If a single transaction violates the gas limit, that transaction just never makes it into a block. Even though we have a gas limit for blocks now, that's more about how we ensure that blocks happen at a given time. If we're not going to do that, then that doesn't work anymore.
Even a gas limit per transaction, which I'm not opposed to, isn't enough to give us a global gas limit. Global meaning, like a per validator gas limit.
But is that with the assumption of a block time as well?
If we have a block time and a block gas limit, then we can kind of say what the validator gas rate is going to be, or like the gas capacity required per validator is going to be.
All right, and then how do we shard that, right? Because in a given shard, the slowest node is not going to be the globally slowest node.
Of course, yeah. I mean, basically, like we just like have to like assume that like nodes have at least some capacity, and then you can like use that as an assumption in your sharding thing, and then like that number doesn't need to be an assumption. Actually, it could be something that's the protocol targets as a function of like demand and like the amount of validators who are going offline.
Okay, but that sort of doesn't work for the other. But that's you still have a problem there, right? Because okay, let's say I'm on a really fast shard, and I'm blowing through my gas. Am I idling as a node? Am I underutilized, or am I making blocks faster than other shards?
So I mean, like basically, like you're going to be idling, and if you're idling too much, you might consider like splitting your bond into two and having two spots, and just like validating on two shards.
So Vlad, can you describe the nature of the limit? What are the dimensions of the limit? Is it gas per transaction, gas per transition in the virtual machine?
The important thing, so I mean, every transition in the virtual machine has some gas in the schedule. The thing that we need to have is like the property that like we can say a validator will not need more than X gas per second to validate, like at least for some period of time. So the important thing is bounding the overhead of validators. With the gas.
Oh, I see what you're saying, because they can't serve. So like a validator would not be able to serve n number of clients if they were all making n isolated steps, and the sum of the gas for each step was greater than some bound.
Yeah, for example.
Please post that into the overhead bin and have your items under the seat.
Rangez vos bagages dans un coffre supérieur. Que les bagages plus lourds sous le siège devant vous. En prévision du décollage, assoyez-vous confortablement. Bonne réception.
Right. And so what's the natural measure of that?
In preparation for takeoff, make sure your
Right now we just like have like gas, right? I mean, gas is measured just like this.
No, but that's no.
State
This is but this is different, right? This is not. It's not just that you have gas. What you're saying is that any particular validator doesn't have a certain amount of concurrent capacity.
I mean, I'm actually not sure what concurrency has to do with it actually, because like whether you're executing concurrently or serially, like your gas like schedule is going to give you the same like gas count in the end, and like that like has to be like less than some bound, you know, whatever in the end means.
No. Let's say that we have that we're measuring this in terms of the time, the smallest unit of time required to take exactly one step.
No. We're measuring it according to the gas schedule, right? There's like state transitions in the virtual machine, and each one has like a gas price.
Right.
Sorry,
That's
gas cost.
And
Yeah.
each one of those transitions has a time associated with it as well, is what Greg is saying.
Okay.
Yeah, exactly.
Yeah.
So in particular, what I'm imagining is, imagine that you actually had a concurrent VM, right? And so it could make, in steps simultaneously.
Of course, yeah. All of that would need to be counted in, like, and I mean, in my starting solution, like, I have like, a way to like total gas spent by a transaction and make sure it's less than the out of gas, than like less than the gas is allocated, and so that like to make sure that like the thin out isn't like unbounded.
Right. So what the gas limit here seems to say seems to describe a kind of concurrency constraint. You could only have so many logical threads of execution.
I mean, that's definitely, it is definitely a concurrency restraint, but it's also a restraint on sequential computation.
Oh yeah, of course. No, I see that as well. But I'm just saying at the bottom, right, where you've atomized this down to every logical thread is making exactly one step, and none of them are stepping on each other's toes, so they don't have to be serialized. Then what you're describing is the total number of logical threads that's available in a given validator at a given time.
Yeah, that's one of the things I'm describing.
Okay. So it's
the reason for that is basically like that we have to make sure that weak nodes can stay synced up.
Well, ladies and gentlemen, Scott speaking with that update.
so what that says then is if some party has invested a lot of money in building out very fast hardware, like super concurrent hardware, then there's a limit beyond which it's not profitable for them to build.
Well, in a non-scalable blockchain, that's certainly true. But in a scalable blockchain, they could reserve multiple nodes, and in a scalable blockchain with heterogeneous sharding, they could provide like one node for tax capacity. Potentially, I mean, if
Anything
they're
else changes, I'll get back to you. Thanks very much for your patience.
I'm not sure I see the difference.
So you mean between sharding and non-sharding?
Yeah, maybe it's because in my mind it's all sharded.
Yeah, maybe. So I mean, like, if you have like this high capacity node, then you can like, serve as like end validators, right?
Yeah, but that's something that you have to do. That's an operation, no pun intended.
What do you mean?
Yeah.
It's not
Oh, yeah,
inherent in
totally.
the language.
That's right. I agree. Yeah. So this is something that you have to do on the node level. You're gonna basically have to be like running 5 validator nodes or whatever on this one like mainframe that you have or whatever it is.
Okay. So So then the gas limit is all it's just saying is how wide any given logical validator can be.
Yeah, basically, it specifies like a minimum capacity.
No, it specifies a maximum capacity, right? You can't go faster than this.
Well, I mean, that's true. But what I mean is like, it also says that if you can go this fast, then you'll be able to keep up. But if you can't go this fast, then you might fall behind.
Okay, I understand.
So it serves as like a minimum capacity in the sense that like any node should only join if they have a higher capacity than this. And if you have like multiple n capacity of that, then you just should make n nodes.
But what if people don't do that, right? If they don't do that, then doesn't it screw everything up?
No, it just screws their returns. They're gonna have like higher operating expenses for like running a small node.
But what if they're on a? But isn't that going to make their shards faster? Like if enough.
No, not necessarily, right? Because they are like their gas limit is going to be set like not on a per shard basis, but on a cross shard basis. At least in my first sharding solution.
So yeah, so I think it's the naive idea there would be that. I mean, to me, it almost makes sense that some shards would just be faster than others, right? And then you don't have to create multiple nodes. You don't have to try and balance your capacity across entities on the network, right?
Yeah, and I think long term that is our plan. But at the meantime, it's like a little bit more complex because the assurance that we have that there's not going to be someone who forms a monopoly on the shard is a lot weaker in that setting, and so we have to like isolate the possible consequences of this, right? So imagine if you like let just like shards go at any gas speed, then like I would make like an ASIC that serves only like one contract in my shard, and I would be the only one who serves it, and then like I would make like an invalid transition, and like that would like cascade across any shards, and like no one would be able to like really tell until it's too late.
No one will be able to tell what? I'm not sure I'm following.
No one would be able to tell that I made an invalid transition because no one could keep up with my shard because I'm the only one with the ASIC who can do it.
But shouldn't we just never merge that then, right?
Right, exactly. So that's what I mean by isolation. You need to like have isolation between shards if you're going to have something run much faster than others.
Well, but the thing is that if that contract never interacts with any other contract.
Okay, so I'm assuming it does, right? I'm assuming it's just like sending things willy-nilly across all the other shards.
Okay, but then at that point, then there is potentially, if there's an invalid transition, that means there's going to be some conflict with some other proposed block.
But people won't be able to tell that it's invalid, right?
You will, because
well, no, they can't sync up on that shard. It's going too fast.
What do you mean by sync up, right? I mean
they can't like actually check whether the blocks are valid because they have too many of them to go through.
Right, but the problem is that they won't be they won't be part of the consensus. So it will be as if they've been partitioned off. They're in their own isolated network.
But surely like you should be able to have a contract on a shard that does.
But then they'll never make transaction fees because no one else can keep up, and because no one else can keep up, they die.
Other shards shouldn't have to validate blocks from other shards, right? I mean, that's kind of the point.
I hear. That's why I asked for interaction. If there aren't cross-shard calls that will affect consensus on both shards, then that shard can go off and do whatever it wants.
Yeah, of course.
Only once they start interacting.
Of course, yeah. But once they start interacting, it still doesn't create an obligation for all the other shards to go and validate those blocks.
But for any shard which does have a consensus requirement because it actually affects the schedule or order of transaction, they will have to keep up. There will have to be consensus.
That's a significant scaling limit that you've just imposed, because now my shard needs to keep track of any shard that sends me an incoming message.
No, only if there's any sort of like if it's an async message, if it's a fire and forget, you don't care.
No, because I want to have atomic ASIC messages.
Even with atomic, well, maybe I don't understand what you mean by those. I was talking about fire and forget, where it's a one.
So to me, like the contract sending the message by fire and forget, but the system never forgets.
Never forgets what. What I mean by forget is there's no consequence with respect to consensus.
Okay, right. So I imagine that the incoming message will affect some state.
Okay, all right.
But anyways, I need to go because the plane is about to.
No worries. No worries.
But yeah, we should continue this conversation, and next week I'm gonna be in Cornell, and then it's gonna be really heads down for me.
Cool. Yeah, I'm making travel plans to head out there. Enjoy.
Great. Awesome. Keep me posted.
Okay.
Nice chatting, Rick. Bye, everyone.
Yep. Are you on your way here?
Yeah, I'm on my way to New York now.
Okay, cool.
Cheers.
Yeah, bye.
All right. See you, bud. Does anyone else have any other updates?
I don't. Aaron, are you in New York?
Yeah, I am.
Do you live in New York, or are you here for the conference?
I'm here for the conference now.
Oh, cool. Yeah, I live in New York, so I'm thinking about going to some parties and stuff after the conference. I didn't really want to pay for it.
Yeah, I got a pass from someone, so I'm good. But no, I used to live here, so I was already back in town just visiting my old friends.
Oh, cool.
That's what brings me here.
How was your father's performance?
Oh, that was great. I'm going again tonight.
Oh, wow. Wow.
Fun.
I hope many legs are broken.
Yeah, it's an opera about jealousy, so tragic deaths all around.
Exactly. Awesome.
Yeah.
Rick, do you understand so Vitalik had a nice back-off protocol to achieve partial synchrony, and then he modified it slightly, and I didn't catch the modification recently, and I was wondering, do you have that? You have your finger on that?
No, not at all. I have a really difficult time following what progress is being made where. Actually, I'm idling in the Skype channel, but that is frankly fairly noisy.
Yes, it is. Yeah.
So I do see documents that come out from him, and they're usually significant in their size. So I have a hard time following along, frankly.
Okay. Yeah. No, I'm. Yeah. I really liked the back off protocol, but he seemed to say that there was a vulnerability to that and modified it. And we talked about it. I think it was last week, but then I forgot to review it, and then lost track of what exactly the modification was. So I'll ask him next week.
And he just posts all his messages to the Skype, or is there another channel?
I'm not sure. I think that they've tried to link up all the channels. So I just follow the Skype because I operating under the assumption that that's linked to all the other, because there's also an Ethereum research channel on Gitter.
Yeah, that's correct. The Gitter, the IRC, and the Skype are all linked. That's why it got so noisy recently.
Yeah, that's what I thought. That's exactly what I thought.
What's the IRC one?
I don't know. I know it exists.
Exactly.
Yeah, I think I'm in the Gitter one already.
Yeah, the Gitter research one will give you everything as well. The only thing, if you want to privately chat to the Skype people, is send a message on Skype, then edit it within Skype. The edits don't sync.
Oh, interesting.
Right. Right.
Hey, Greg,
Yeah.
let me ask you something about the propositions.
Yeah. Sure.
Like, so we were discussing last week that we're doing propositions such as, determining which transactions play nice with each other, so are consistent.
Yeah.
Do you also make propositions about other propositions?
No, I don't allow that.
Oh, why? Like, this proposition and this proposition don't conflict. So it's like merging two, for example.
Right. Because since I already have proof rules, you can detect that. You don't have to make a proposition about that. The logic I built has what's called the small model property, which means that the logic, the propositions are valid if and only if you can build a model.
I don't know what that means right now.
So in other words, if you look at the document here, I'll find the document for you.
No, I mean, all I'm saying is, like, suppose, there's the two propositions about, one says A and B are compatible, one says C and D are compatible. So would we need another proposition that says, oh, A, B, C, and D all together work fine together?
No, they auto merge, is what he's saying. They automatically merge into.
Yeah.
Yeah. How?
So I'm assuming.
How does that work? I mean, there's content in that merging. It's not like there's just as much information in one of these merges than there is in a proposition to begin with. Proposition says.
Yeah. So I have more information about the transactions than I believe the Ethereum virtual machine does. So I'm assuming that I can that I've got namespace control, and I mean, actually Ethereum has namespace control as well, right? Because all transactions ultimately have to hit addresses, and Ethereum is in complete control over the addresses. So you can detect it. So if you have a logic over the namespace itself, then you can detect when transactions collide over addresses. And if they collide over addresses, you know there's conflict. Or you just assume there's conflict. And so there has to be some ordering.
Right.
Sorry, I dropped off there for a second.
No worries.
But I still don't see how you can automatically merge propositions, but not automatically generate propositions.
So by merging and generating, we may be sort of talking past each other in terms of our language.
Quite possibly.
Yeah. So there's a kind of isomorphism between propositions and collections of blockchains, which is described in the paper. So if you have a collection of blockchains, I'm pretty sure in this logic that you can get what's called a characteristic formula. So if you hand me a collection of chains, I can auto-generate a proposition, the smallest proposition that denotes that set of blockchains.
Or the largest consistent okay, no, I got it. Largest consistent set that determines that set of chains.
Right. But since you can conjoin and disjoin and all of that, it's really just one proposition.
Yeah, sure.
Yeah. Okay. So in that sense, at that level of detail, we're probably saying the same thing. I just what I thought you were referring to initially was something slightly different, where you have a meta logic, which is saying things about the propositions themselves. such as
No, but probably just talking about conjoining propositions.
yeah, okay, yeah. We can definitely conjoin propositions. That's a part
No,
of.
but that's a new proposition. Or you were saying that's automatic.
Yeah, I mean, so any set of propositions is going to correspond, in fact, to a proposition.
Right.
Right. Depending on whether you treat that set as a disjunction or a conjunction. And it can be more complicated than that, right? Well, we haven't really talked about how the isolation and dependency of transactions can bubble up into the isolation and dependency of whole propositions. So effectively, there's going to be a kind of linear. There are some linear operators that exist at the transaction level, and you can lift those all the way up to the chain level.
Okay.
Does that make sense? You understand what I'm saying? So if you know that two transactions are operating on completely isolated address spaces, then you can imagine that you've got two isolated groups of transactions.
Yeah, but you can't know that until you run the transaction all the way through.
That's not true. That's exactly what I've been trying to say with all of these papers. From beginning with linear types can change the blockchain. That's just
Well, you can if you put that semantics in a high-level language, but you can't if you have just low-level bytecode running that's Turing complete.
No, that's also not true. Depends on what you say the bytecode is.
If you have code that can load and store addresses and change those addresses given some input data, then call those addresses, you have no idea what address they're going to call.
Again, that's not true, and that's sort of that's the whole point of the linear types can change the blockchain.
Okay, so if you have a transaction that has an input and that input goes through a hash function, and you call the result of the hash function as address, you have if the hash function is not broken, there's no way to know beforehand the pre-image of the hash function.
Right, but what you can track, the main thing is you have to be able to track inputs to the addresses, and you have to be able to know whether or not, like in the case of the hash function, you can't necessarily know the address downstream, but you can make assumptions. You can make defensive assumptions about ranges of addresses, and you're right. That's the best. That's the best you can do. And at that point, what you do is you have two choices. Either the well-typed programs will converge, so they're not Turing complete, or your types are less discriminating, so you'll have false positives.
But okay, so here's where I'm stuck at though. Like assembly code doesn't see any types. I mean, we've got i32 registers and i64-bit registers. Some Intels have 128-bit registers.
You're making an assumption that you're not using a typed virtual machine. So you do your correctness at the level of where you have the domain information, right? And then all compilation steps past that, it's already been type checked, so you don't care.
Yeah, but you're relying off high-level information there.
Right.
It's not.
Which is part of the domain, right? The notion of addresses is fundamental to the execution of Ethereum. And like if I convert the whole world into a non Ethereum address thing, then I can't even guarantee Ethereum semantics. So there's a point at which the domain semantics actually is crucial, and below that point where you translate down to the metal, you've lost all that information. So you have to do your correctness at the point where you're still operating within the semantic domain.
And so the semantic domain here is the Merkle tree. When you talk about addresses, is that what you mean?
For me, the address space is absolutely critical, because that whether you model that using Merkle trees or not is a separate. Right.
Well,
So what I'm trying to argue is that the address space or the namespace is kind of the bedrock, right? Because all communication is going to be facilitated by some kind of address space.
Right. Okay, I agree with you. This address space is sort of the framework for which everything.
Exactly. And then what? But the address space is will per force have addresses will have an interior structure if you do this kind of reasonably or rationally. If they're just atoms, then then you've lost crucial information. So the addresses have to have an interior structure, which basically is described by some algebra. Once you
I'm sorry to interrupt, but that's like the V-node structure. When you're talking about the address structure there, you're talking about like the virtual nodes in Cassandra, right?
It's very similar. It's very similar. That's exactly right. Yeah. But once you have this address space, the logic of the address space, then that gives you enough to say when things, like when things are hitting the same addresses and when they're not, right? And yes, you're right. You can do all kinds of calculations on the addresses, and so there are basically two options there. Either you have typed terms, which say so much about the types, say so much about the terms that they can't, that the well-typed terms can't be Turing complete, or the types say less about the terms and you get false positives. So yes, there will be some terms where a programmer potentially knows better than the compiler about the behavior. And at that point, what you can say is ignore the typing warnings. I know what I'm doing, right? But then everybody will be alerted to the fact that this contract has declared that it knows better than the compiler about how to manipulate addresses, and they can make their own decisions about whether or not that's safe. But it's declared up front.
Right. Sure. So but what started? If we pop up the conversation is that in scaling, like you don't really know if what the contract is going to call. I think that was the whole point.
No, but the point is that you do know, you can track the use of addresses from contract to contract.
Okay.
And so when you compose contracts, then you can also track the use of addresses. And when you compose those, you can track the use of addresses.
Right. Martin, basically what he's saying is don't do that.
No,
I'm
not saying that at all. I'm not saying that at all. What I'm saying is that this is now well established in both the security and the protocol protocol space. So everything from region analysis, you can actually with types determine the lifetimes of objects.
Right. So I think to do what Martin is talking about, you have to do some wonky type mutation in there in order for his example to even happen, right?
So in his example, he doesn't have the how do I say this?
I don't have types because I'm only thinking about bytecode.
Right. You're thinking about untyped bytecode. But
Well, I'm thinking in terms of registers.
Again, it's perfectly reasonable to have a typed VM. There's lots and lots of those.
Right. So I think that's where you guys are sort of talking cross purposes, right? Martin is imagining a world where the language doesn't allow for the type of detection that you're talking about, and then saying the type of optimization that you're talking about is impossible. But really, you just have to add that in, and I think it's pretty easy to add.
Yeah, I'm not saying it's impossible. It just it moves to the interface.
Right. So
The system interface. So here, the Ethereum EVM Design 2 interface. So it needs to be moved into this part of the design and not the VM. How do I paste stuff? Where's the chat? Here we go. So you see that link? Like,
yeah, hang on.
that is where. So right now, the system interface for EVM2 just simply copies EVM1, but for scaling, this is where the work is going to have to go into the interface between like the low-level instruction set and these higher-level semantics.
Right, and this is where the typing would happen, right?
That's exactly right. That's what I've been arguing for. Yeah.
Well, yeah, I guess so. The typing would happen in call, I guess. I'm not sure.
No, not in call. It's
call becomes typed.
Yeah, every call is typed, right?
Right, but we start out with just instruction set.
Make a typed instruction set. That's the point. You can make a typed instruction set.
Right, but how do you make a typed instruction set out of an untyped instruction set?
You can also do that. I have like the same algorithm that I use to generate the logic for betting. You can use to generate typed things. So you start with a language, and you start with the means of collecting how you want to collect programs that are that inhabit a particular type. So you could collect them in sets, you could collect them in lists, you could collect them in trees, etc., etc. So depending on how you collect terms that are typed, then you can auto-generate the corresponding typed widget.
So I was gonna write out initial sort of interface, but I was for composing contracts. But the typing system that I was looking at was what was proposed in bigraphs.
Yeah, I mean, you can always.
You can totally. I mean, it's pretty simple to imagine bigraph interfaces in terms of like those low-level semantics. But yeah, that's.
Right. So the issue with that is you're starting from something that's extrinsically defined, right? It's not in any way initially related to this instruction set, and so you're going to have to find you're going to have to look for the map from one to the other. So what I'm talking about is beginning with your existing language. There's an algorithm which will convert untyped languages to typed languages. And we've run this algorithm over lots and lots of sort of famous examples, and that's I can show you how the algorithm works. It's really very straightforward. So that way you're guaranteed to get a typed system at the end. Whether or not you can find a map from bigraphs to this instruction set, probably there's one. I don't know. You know?
Well, no, I think you're missing the point. There isn't a map from bigraphs to any particular instruction set. There's simply a map between how contracts can call each other and how they can fit together, and and bigraphs.
Again, you're going to have to relate that to your instructions. However you plan to do that, the notion, there's a very specific relationship between terms and types. and we kind of know what that relationship is, and it has to do with, how do I describe this? The best way to describe it is you want the denotation of the types to be exactly those terms that inhabit the types. So that's called realizability. So the meaning of the types is the set of all programs that inhabit that type. And once you have that kind of constraint, then calculating the typed terms from an untyped set or from an untyped language together with how you collect your terms is completely straightforward. There's not a lot of wiggle room. It's totally algorithmic. So I mean, you can either run the algorithm or you can try to do it by hand. You know, those are kind of the options available to you. Anyway, we have a typed version already mapped out. That's sort of what the whole nested Casper idea is. So if that would help as well, so the typed version of the VM will be probably available in the next 3 weeks. So you can see how we're doing a typed VM. That might also help.
How do I run it?
How do we run it? Well, we're writing
No, sorry. How do I run it?
How do you run what? The VM?
Yep.
Yeah, so we're implementing it in Scala. So I'll make the code available in discrete chunks. We've already got the parser for the high-level language, as I was saying at the top, and the internal architecture is described in terms of different grammars. So each different, so like the instruction set will also be described by BNFC. That's kind of our next step over the next week or two, is to describe the instruction set using BNFC. And what that gives us is a one spec which auto-generates both the on-wire representation and the storage representation and the in-memory representation. So so that's all completely, you know, auto. We don't have any, you know, by hand written code for that. We have one spec that generates all of that.
Is the spec online?
So we have the spec for the high-level language, and now we're doing the spec for the instruction set. That's the next step. So that so I'll be publishing that in the next 2 or 3 weeks.
And what's the spec written in?
The spec is written in BNFC. Here, I'll give you a link. Okay, it looks like we're running over, so we should probably ring off. But yeah, next Monday, we'll probably have even a draft spec by next Monday, Martin, so you can take a look at it at that point.
Okay, cool.
Yeah. Awesome. Sweet. All right, guys.
Man.
Have a good week.
Right.
How long, Aaron, are you going to be in, are you thinking about stopping by the West Coast, or how long are you going to be in the U.S.?
Not on this trip. I'm staying here until the 11th and then back to Europe.
Oh, okay. All right, cool.
But
All right.
I'll let you know. Bye for
Well,
now.
all right, ciao for now.